Welcome to this video. This video is on Moving Straight Ahead 1.1 and the LEQ is how is the unit rate related to the equation? So in this problem we're going to be working with walking rates, and walking rate is how fast you walk in a certain amount of time. So there's this class, this teacher who has students who are actually fundraising, just like we're doing with our advisory. They decided that what they want to do with their time and effort is they want to create a walkathon so they can raise money for kids in a hospital. And so they want to determine how much money they can raise. And so they want to decide how they want to get this money for the walkathon. You know, do they want people to give them a flat fee? Do they want them to give them money per kilometer they walk? And so they're trying to make these decisions. But before they can decide that, they want to know how fast they walk so they get an idea of how much money they can raise. So that brings up an interesting question. Do you know your walking rate? Something to think about, like how fast do you walk? Or how would you calculate that? So what happens is they have some volunteers that are going to walk. So the first 3 volunteers walk for 20 meters and their times are listed. And another 3 walk for 10 meters and their times are listed. So how would we combine the groups to get 6 people and be able to find the average walking rate? Well, one way would be, since the first group is double, you could take theirs and divide them in half. So take all their times and divide them in half, because you would figure if it took 15 seconds to walk 20 meters, it would take 7.5 seconds to walk 10 meters. So we did that and took all their times in half. Now that's not the only way. You could do something else, but that was one way. So if I take their times and I add up all 6 of those times and then divide them by 6, the average seconds it takes them to walk would be 6.01 seconds. And that would be to walk 10 meters. So here is the beginning of a proportion, and we're going to use this proportion to figure out how fast they walk. So walk 10 meters, and we're trying to find per second. Notice that the meters and the seconds are diagonal from each other because 10 meters doesn't go with 1 second. They don't walk 10 meters in 1 second. I'm going to figure out how fast they walk. But 10 meters goes with 6 seconds, or 6.01 seconds. And then I'm going to use a proportion and my scale factor to find how many meters they would go in 1 second. And this is the answer that we have. So that's going to be the walking rate, 1.66 meters per second. Now you're going to answer some questions, and we're assuming the 1.66 meters per second is your walking rate. We're taking that to be yours. So when you answer these questions, it says, how long will it take you to walk 500 meters? That's assuming that you're walking 1.66 meters per second. Same thing here. You're going to use the same walking rate for each one. So go ahead and answer B number 1 and B number 2. And I'm going to show you how I use a proportion and get an answer for 10 minutes. And then I'll show you the other way so that we can answer number 3. So if I want to find how many meters I can walk in 10 minutes, if the walking rate I'm going is 1.66 meters per 1 second, and I'm going for 10 minutes. 10 minutes, if I put 10 minutes over here, then my side-by-side labels won't match. So I'm going to change 10 minutes into seconds. So 10 minutes would be the same as, and I'm just going to do this sloppily, 600 seconds, because 10 times 60 is 600. So I apologize for it being so messy, but it's kind of hard to do. Here, there we go. So I'm going to scale from 1 second up to 600. But if I notice, because my walking rate is a unit rate, the scale factor, I end up just multiplying by 600. My scale factor of 600 is the same as the number of seconds. So really, I'm just multiplying 1.66 by the number of seconds, because it's always going to be, since that's per 1 second, then the scale factor is the same as the number of seconds. So I'm going to do 1.66 times 600 seconds, and I get 996 meters. So hopefully yours is neater than mine, but I get 996 meters in 600 seconds. So going back, if I would have done the second one here, if I would have done 30 seconds, instead of setting up as a proportion, I realized that if it's every time I set the proportion up, since it's 1 second in the denominator and I'm scaling up to seconds, it's always going to be this. The scale factor is the number of seconds. So I really just need to multiply the speed in meters per second times the seconds. So if I do 1.66 meters per second times 30 seconds, that answer is going to give me the number of meters, which in the case of 30 seconds is 49.8 meters. So we'll use the same idea for 1 hour, that I'm going to take the 1.66 meters per second, and I'm going to multiply that by 3,600 seconds, and that's going to give me the answer of 5,976 meters. So I'm not going to write it because that would be a mess, but you're going to write it. It says, describe in words the distance in meters you could walk in any given number of seconds. What that's saying is, if you noticed, we are doing the same operation in all three of the problems above, that we are taking the speed and we are multiplying that by the time to get the distance. So we're taking the 1.66 meters per second times the time to get the meters. 1.66 meters per second times the number of seconds, our answer is the meters. 1.66 meters per second times the seconds is the meters. So that's what it's asking. I just described it in words 3 times. So you write it in your own words, and then you can move on to the next part of this video. So now that we've written it in words and we have observed the pattern that we're always multiplying the 1.66 meters per second times the seconds to get the distance, based on that we can now write an equation. So I'm going to start with the unit rate. Our unit rate is 1.66 meters per second. Now, the operation is every time we wanted to find the distance, we multiplied. So what I want you to do now is use that unit rate and the variables given, t for seconds and d for distance, and write an equation on your paper that would work to be able to get the distance given any number of time. So now that you've done that, I'm going to fill this in. So remember, we multiplied the speed times the time. And every time we took the 1.66 meters per second times the seconds, our answer was meters. Our answer was the distance. So your equation is d equals 1.66 t. Now, the question is, I'm sure will be asked that, can I have the 1.66 times t on the left and the d on the right? And that's fine, as long as you're multiplying these two parts together to get the distance, and the distance is on the other side of the equal sign, it doesn't matter what order it's in. I would say this though, your number, when you're multiplying the number, should be in front of the letter because the number is the coefficient and it goes before the letter. So it needs to be not the t in front. So now that we know that, use your equation to find how far, what the distance is in 45 seconds. So I'm going to remind us of the RSS method. RSS. And I know that sounds like a lot of work, but it's just a way to document your work. So RSS, so first you're going to rewrite the equation. This way it's very clear what you're using. Oh, sorry about that. There. Next, I'm going to substitute 45 for the seconds. So D is still a letter. I don't know what D is yet. I'm going to put the 1.66. You're doing all this before you put anything in the calculator. So once you get this set up, and then you're going to multiply the speed times the time, 45 seconds. So then once you have that ready, then you pick up your calculator and you get that the distance equals 74.7 meters. Oh, so close. 74.7 meters. I'm sorry for that line there. And you're like, why? I can just multiply them. I know that, and that's exactly what I did. I just multiplied them too. This is just documentation. This is showing the person, the observer, who's looking at your work to see exactly why you multiplied. This is showing your work, and it's just a systematic way of doing that. So now you were able to. So at this point, you were able to calculate the walking rate and use that walking rate, which is a unit rate, and write an equation. Can you find that walking rate in your equation? It's right here. It's the number that you multiply by to get your answer. And then you were even able to use that equation. So, good job, and thanks for watching.